All right, so yes, quiz tomorrow. First thing I want you to do, everybody take out your homework. There's some questions on the homework that I want to make sure I explain really well, because there's some hard ways to do some of these problems, and there's a really, really easy way to do some of these problems. Right, Abby?
Hey, maybe we should not have our meeting tomorrow. You know, have a deep. And
Yeah. Yeah. Sorry.
Yeah.
Yeah. Okay. So, all right, homework's out. Page 124. Abby, please, for today. 124. I think the first couple problems, and actually everybody open up to page 124. I think the first couple problems are pretty easy. I think you guys have a good, it was 124. And I think the first couple problems are really easy, and I think you guys have a really good handle on those. Like number 2. What's the only thing you got to set up? 5 is to 4 as 7 is to x, right? Be careful with some of those, because sometimes like the triangle gets rotated, right? How can you tell what side goes with what? The easiest way is just look at that similarity statement, right? I think you guys got a good handle on those. Yes? The answer should have been 5.6 or 28 fifths, 28 over 5, either one. Easy? Now, I also think you have a good handle on number 4, which is just another proportion kind of thing. Roger's 5 feet tall, his shadow's 3.5. The flagpole is a 14-foot shadow, so again, it's just setting up a proportion, right? 5 goes with 3.5, as we don't know how tall the flagpole is, but the 14. Now, again, the biggest thing is making sure you set up the proportion correctly. Is there a relationship going sideways? Like, is there a relationship between the 5 and the x? Is there a relationship between the 3.5 and the 14? Yeah, what is the relationship between the 3.5 and the 14? Aren't they both shadows? Right? And then this is basically their height, right? So there is a relationship there. There also has to be a relationship going vertically, up and down. Is there a relationship between the 5 and the 3.5? Yeah, like that's the person and his shadow, right? So as long as you have both relationships established, you're good. The only thing you got to be careful of is not doing something like 5 is to 3.5 as 14 is to x. Why would this be incorrect? Like 5 still goes with 3.5, like that's still a person and his shadow. But what's wrong with this one? Is there a relationship going this way? No, like this person's height, that thing's shadow, there's no relationship there. But I think we're good with those, yes? The one I really want to talk about is number 5. I know you didn't have to do number 5, but there is going to be some of these on the quiz. And there's a hard way to do these, and there's an easy way to do these. We talked a little bit about it yesterday. So it says there's a rectangle, right? And what is it, 8 by 12? Yes? And then it says the new one is made from a scale factor of what? 3/4? Great. We could actually calculate those. What is 12 divided by 4? 3 times 3? 9. So that would be 9, right? If I go 12 times 3/4, I get 9. If I do 8 times 3/4, what's 8 divided by 4? Times 3? 6. Okay? Now, here's the questions on the quiz. What is the ratio of the perimeters. Now, how do you find perimeter? You just add up all the sides, don't you? Well, great. What's 12 plus 8? 20. There'd be another 20, right? So what's the perimeter here? 40? Yes? Great. What's the perimeter over here? What's 9? 9 plus 6 would be 15. I have another 15. That would add up to 30. What's the ratio of the perimeters? Well, it would be 30 to 40, which is going to reduce to 3 over 4. Did I even really need to calculate the perimeters? If the only question is what is the ratio of the perimeters, what's the answer going to be? Whatever the scale factor is, right? Now, here's where it gets a little tricky. What if it asks for the ratio of the areas? Now, how would I find the area of this rectangle? Base times height. What's 12 times 8? 96. Okay. What's 9 times 6? 54. Now, if I do the ratio of the areas, what's 54 divided by 96? Well, that fraction, we'll just use the calculator to reduce the fraction for us. So 54 divided by 96. Oops, I didn't put in a 4, did I? 54, come on, 4 work. Divided by 96. Math, enter, enter. Reduces to, 9/16. Where does the 9/16, whoa, what just happened? Where does the 9/16 come from? Out of the 3/4. It should have been 3/4, shouldn't it? Why is it 9/16? If I put units, this is like 8 inches. Well, the perimeter is going to be 40 inches, right? This would be inches what? Area would be inches squared, wouldn't it? What do you think 3/4 squared is equal to? 3 squared is 9, 4 squared is 16. Area is always squared. So, I want you guys to look at number 12. I want you to look at number 12. It says you have a rectangle has an area of 16. Okay? Do I know how big the sides are? All I know is the area is equal to what? 16, right? All right. I don't know the side lengths, right? But it does say every dimension is multiplied by a scale factor. Okay? So whatever this width is and whatever this length is, it's going to get multiplied by some scale factor, right? The result is a new rectangle that has an area of, what, 64? Now, basically, what is the number that we would multiply that 16 by and get to 64? Is this number going to be the same as that scale factor? No. If it was perimeter, it would be. But this number is not. It's going to be this number squared. If this is a 2, this would be a 4. If this is a 3, this would be a 9, right? So we got to figure out what this number is. How would I figure this number out? 16 times what is equal to 64? How do I figure that number out? Divide. What's 64 divided by 16? 4. So that means the scale factor is 2. Does that make sense? The scale factor, if it's perimeter, it'll be the same. That always gets multiplied. Area, it's always going to be squared. What do you think happens if it's a cube? Let's say we have a box that's 3 by 3 by 3. And I say the volume is 3 times 3 times 3, or 27, right? What do you think would happen if I say, let's use a scale factor of 2 and double that box? So now it's 6 by 6 by 6, right? So now my volume is 6 times 6 times 6, or whatever the heck that is. 36 times 6 is 216, I think. What's the ratio of these two volumes? Is it going to be the same as this? No. It's not even going to be this. It's not going to be 2 squared either. Volume, if this is inches, this would be 27 inches what? Cubed, isn't it? The ratio of the volumes is going to be 8. 2 times 2 times 2, or 2 cubed. Does that make sense? Just easy kind of stuff? To the point of this. Here's your homework today. And I want to do a couple problems with you together. Real easy. I want everybody to look at the side 2-7 first. Here, give one of those. All right, we're all on side 2-7. I want you to look at number 7. Well, basically right at the bottom, 4, 5, 6, and 7, right? What it says first is every dimension is multiplied by what? What's the scale factor for this whole situation? It's 2, right? I want you to look at question number 7. Skip all the way down to number 7. It says, what is the ratio of the perimeters? Now, we could go back through and do the whole problem. But in all reality, it doesn't matter. What's the ratio of the perimeters going to end up being? The ratio of the perimeters will always be the same as the scale factor. The answer to number 7 is 2. It doesn't matter what the shape is. It doesn't matter what the numbers are. The ratio of the perimeters is always going to be the same as the scale factor. If you look at number 9, it says, what is the ratio of the areas? Now, is that going to equal the same as the scale factor? No. It'll be the scale factor what? Squared. So what's the answer? 4. It doesn't matter about the rest of the numbers. You can do it that easy. Now, do we still have to go back through and, all right, so number 4. If the scale factor is 2, what's the new dimensions of rectangle B? Instead of 2 by 6, it's going to be 4 by 12. Okay, so that one's easy, right? And yes, to fill out, what's the ratio of the corresponding sides? Well, what's the ratio of the corresponding sides going to be? That's going to always be the same as the scale factor, which is 2. The ratio questions, you can do it by calculating the sides and dividing. Or if you just know the side lengths will have the same as the scale factor, the perimeter is going to be the same as the scale factor, but the area is going to be the scale factor squared. Does that make sense? I think that's an easier way to do that question. Are we good with these? I think the rest of them you guys are pretty good at. Like 1, 2, and 3, set up your proportions and solve those. Number 3, find the shadow length, make sure your relationships match. But the ones I really wanted to make sure you guys are good at are all the ratio questions. Does everybody understand what I was just talking about? Of how those work and how they're going to be, when are they going to be the same as a scale factor? On tomorrow's quiz, there's going to be a situation just like this on the bottom. There's going to be a question. It might say, what's the ratio of the perimeters? The answer to this should always be the same as what? Whatever the scale factor is. It might say, what is the ratio of the areas? That answer will be whatever the scale factor is squared. If it says, what's the ratio of the volumes, if let's say it's a box or something like that, it'll always be the scale factor cubed. Just raise it to the third power and you're done. You don't actually need to calculate anything. Are we good with those? All right, so are we good with the rest of this worksheet 2.7? Easy? All right, on the side 2.6. Now, we were doing pretty well with these, but I did feel like we needed a little bit more practice, especially with questions like number 9. How do you do x minus 4 over 6 is equal to x plus 2 over 12? When we do these, we have to first butterfly. But when you butterfly, how do you do x minus 4 times 12? You have to remember to distribute. 12 times x minus 4 is going to be 12x minus 48, right? Then I have to go the other way, and I have to do 6 times x plus 2, which again I have to distribute, which gives me 6x plus 12. Now I just have an equation with x's on both sides. So I want to get all the x's on one side, so I'm going to minus 6x, which gives me 6x minus 48 equals 12. Add that 48. What's that, 60? 6x, divide by 6, and what's my answer? 10. And again, come quiz time, can you check your answers? Yeah, number 10, you do the exact same thing. Distribute, yeah. So, number 10, y plus 2 is to y plus 7, as 11 is to 31. So we butterfly. What's y plus 2 times 31? 31y plus 62 is equal to 11y plus 77. And then you just got to solve from there. Tomorrow's quiz is only going to be on these two sections. It's going to look almost identical to this worksheet. There's going to be a few of these. Yes, there will be a couple easier ones like number 5 or I wanted this one because this one had more of the ones you had to distribute. So, yes, there probably will be some other easier ones similar to just 5 is to 12 as x is to, 36, something like this, where all you do is butterfly. 5 times 36, divide that by 12. So there'll probably be some easier ones like that as well. But there will be some that you have to distribute. And then there will be some just like 2.7. If you can do this worksheet pretty easy, tomorrow's quiz should feel very, very easy. Yes? Number 10? Sure. That's this one, right? So, I would minus the 11y, which gives me 20y, plus 62 equals 77. Minus 62 which gives me what? 15? Equals 20y. So when I divide 15 divided by 20, well, that will just reduce to 3/4. So y equals 3/4 would probably be the best answer. If you put 0.75, that's fine too. What'd you get?
Yeah, I got 1.2, I did 20.
How'd you? What did you get to 15 here?
Yeah, I just divided 20.
Oh, you went 20 divided by 15? Yeah. Remember, you're moving things away from the y, so I'm not going to divide by 15 to bring the 15 to the y. I need to get the 20 away from the 15, so I'm going to divide by 20. Make sense? And again, should you be able to check your answers here? Yes. If you go back in to the very beginning and we say 0.75 is the right answer, you should be able to go 0.75 plus 2 is to 0.75 plus 7, and that should be the same as 11 over 31. Now this one's kind of ugly, it's some decimals. The way I would check it is just figure out what the decimals are. What's 2.75? Because 2 plus 0.75 would be 2.75, right? If I divide that by 7 plus 0.75, or 7.75, figure out what that decimal is, which is 0.354. Okay, well, what's 11 out of 31? What am I hoping for? I just want it to be the same thing, which sure enough, it is. Okay? So you should be able to check your answers as well. Are we good with these? Yes. Number 8? Sure. I don't know. I don't have an answer key in front of me. Let's do it. So 4 over y plus 2, 10 over 5y. So 4 times 5y would be 20y. 10 times y plus 2 would be 10y plus 20. I'd minus 10y. So you get 10y equals 20. Divide by 10. And yep, y is 2. All right. What's number 7 say? Negative 4 is to 0.8, as 2 is to s minus 1. Now, multiplying this way is pretty easy. 2 times 0.8, that's just 1.6, right? Multiplying the other way is where people are going to make their mistakes. What's negative 4 times s? Negative 4s. Negative 4 and the negative 1 makes positive 4. That's where people are going to make their mistakes. They'll still put minus 4 there. A negative times a negative would be a positive. So now I'm at a minus 4. So what's 1.6 minus 4? Negative, is that 2.4? Equals negative 4s. The negatives are going to end up canceling. And then 2.4 divided by 4 as a decimal is 0.6. That would be a correct answer, or you could write 3/5. Say that one more time.
Does it really matter which way you times by?
Like, are you saying, does it matter if I go this way or this way first? Absolutely not. It makes no difference. The only thing that would change would be, instead of getting this on the first line, I'd get the negative 4 s plus 4 on the left side equals 1.6. It would be the exact same thing. I would just The only difference is instead of saying 0.6 equals S, I'll probably get S equals 0.6 in the very end. So other than that, it should be the same thing. You want to do 11 and 12? All right, what's 11 say? A model of a building was built to scale 1 to what? 1 to 65.5. Okay. One side of the model is 23. Okay. How long is it? How long in feet is the side of the actual building? Okay. So, what's your proportion? 1 is to 65.5 as, but where does the 23 go? Top or bottom? Which is the smaller, like, if these were, like, one of these is going to be the model length, one's going to be the actual building length. Which one's going to be the model, which one's going to be the actual building? Doesn't the small one have to be the model? You're not going to make a model of a building that's bigger than the actual building, right? So this is model to building, right? So you got to remember to do model to building. 23 is the model, isn't it? So that goes on top. So what's 23 times 65 and a half? There's your answer. Yeah, it's probably a pretty tall building. There you go.
Is number 5 and 6, like,
I don't have an answer key in front of you, so I can do them.
I did them. I got negative 0.6 and then
So number 5, what you're going to end up calculating, number 5, you would do 6 times a negative 2 1/4, right? Which is negative 13 and a half, and then divide that by 9. The answer is negative 1 1/2.
How'd you get it?
did I put 5?
Number 6.
Oh, no.
I gave up.
All right, are we good on this worksheet?
I got negative 0.5.
All right, so